Welcome to EEE 2232 Basic Electrical and Electronics Measurements. I am Mr. Oladokun AS, and I'll be taking you a brief introduction into basic electrical and electronics measurements. This course is a 1 unit course, and it's actually a practical course. It's a course that we should um, be examining in or that should be taught in a laboratory. Unfortunately, due to the current lockdown in the various countries around the world, including Nigeria, due to the COVID-19 pandemic, um, it has made it physically impossible for us to be in a laboratory to audit this laboratory course. And that in itself poses a unique challenge to this particular course. Unlike other courses that are theoretical in nature, having video lectures or online lectures just my work. It's easier for video lectures and online lectures to be effective for theoretical courses, but for practical courses, laboratory courses like this, there's a unique challenge in that uh, the course in itself should be filled with experiments where students have hands-on experience on when it comes to the equipment. Students are meant to actually see and make use of the various laboratory equipment. So, well, notwithstanding, I've thought about a way to still work around this to find a loophole around this challenge, and that is to use a virtual laboratory. So in this course, I will start by using a whiteboard, a mini whiteboard, to give a brief introduction on some theoretical principles. Then afterwards, I'll switch to a virtual laboratory. So we'll have some virtual laboratory equipment, some virtual instruments that have been modeled to, as much as possible, work like the actual thing. Uh, They can't replace, they cannot replace the actual physical equipment, but they are modeled to work as close as possible, to mimic as close as possible the actual laboratory equipment. So I'll be making use of a virtual laboratory in this course to help with that, to circumvent the challenge we have of students having to not having the opportunity to actually um, operate this laboratory equipment, which is vital for any practical course or any laboratory course. Um, this course should be taught by not just myself, but also Mr. Akoni, from the chief technologist from University of Ibadan. But due to our unique situation, uh, I would be going through this series or these modules um, one after the other to give a kind of a preliminary knowledge. Hopefully, when the world resumes its compulsory holiday, Mr. Akoni would then um, run the various experiments that we are going to be examining or auditing in the virtual laboratory uh, of this online course. So we will go through some experiments on the virtual laboratory, and then when everything gets back to normal, Mr. Connie would go through the physical experiments or the physical implementation of those virtual experiments that will be running in these modules. And it should not be a strange thing. It should be easier. It should be faster for you to grasp the concepts at that time because you've done the virtual version. So it will just be it saves us time if we go through it in a virtual laboratory before later on we do the physical implementation. So this is module one, and I implore you to pay attention closely, and I'll be switching to the whiteboard for some basic background knowledge before we go into the virtual laboratory. Um, we're talking about measuring basic um, basic terms, basic phenomena, electrical stroke electronic phenomena. So we'll be measuring likes of we measure voltage, we measure current, we'll measure resistance, we also measure frequency. So we'll start by voltage. We'll start with voltage. So what is voltage? We'll start by defining. We have to define some of these terms. If you're going to measure voltage, we need to first of all know what voltage is. So see, a voltage is the difference in electric potential. So the voltage is the difference in potential. Difference in potential between 2 points. For example, if you have a battery like this, if you have a battery, and this is the positive and the negative of the battery, the difference in the potential between these 2 points is the potential difference, also called voltage. So there are two electrical potential points. For example, if this is plus 1.5 volts and this is 0 volts, and that means the potential difference, PD, potential difference, which is also the voltage, V, equal to 1 point or plus 1.5 volts minus 0 volts, which is equal to plus 1.5 volts. So this is the potential difference across a battery, a single
finger-sized battery. So that is what voltage is basically. It's the difference in potential between 2 points. So let's go to current. So what is current? Current is the rate of flow. Current is the rate of flow of electric charges in electric circuit. So for example, if you need a voltage source actually. If you have a voltage source, now the symbol for a voltage source is a DC voltage source. It's like this: the positive terminal you use with the longer dash, and the negative terminal with a shorter dash. Then you draw the circuit this way. Now, if you have a resistor here, a resistor connected to a voltage source, a current flow from the positive terminal to the negative terminal. So this is the direction of current. Or in other words, here, high flows this way. It flows from the positive terminal through the resistor to the negative terminal. And this is DC voltage source. So this brings us to Ohm's law. It says that voltage across a resistor is directly proportional to current rate flowing through it. In other words, V is directly proportional to high, current high. In other words, V equal to R I, where R is resistance, is where R resistance is constant. The resistance is constant. Let's go. Let's see. Let's go. Types of voltages based on the direction of the flow of current. We have one alternating current, that is AC voltage, and two direct current, which is DC voltage. So we have alternating currents, AC voltage, and we have DC voltage. So those are the types of voltages based on direction of the flow of current. So let's start from AC voltage. So if I want to draw the AC voltage source, is usually drawn like so. AC voltage, what makes it alternating voltage, alternating current voltage, is the waveform. The waveform for AC voltage, or rather, from the waveform. So let's go. AC voltage. Let's start with the waveform. On the vertical axis, you have the voltage, your voltage V, and here you have time T. So what makes AC voltage alternating is that the voltage rises steadily from one value to peak value, peak V, peak value drops to 0, and then from 0 goes down to negative V, peak, and rise back off again, then continues that trend. So this is the waveform for AC voltage. A typical AC voltage is sinusoidal waveform, sinusoidal in form. And you can see it's actually alternating from 0 to V peak, positive V peak, and then from positive V peak back to 0, then from 0 to negative V peak, from negative V peak back to 0, then to positive V peak to 0, and then it continues to repeat itself over time. And if you want to draw the circuit, this is the waveform. Circuit, you represent an AC voltage source by a symbol that looks like this. This is a resistor R. Now, this is how you connect. You can connect an AC voltage source to a load or a resistor of the form. Now, for example, if I replace this resistor, instead of using a resistor, you can use another kind of load, a resistive or an inductive load. For example, if I use a bulb, an electric bulb, if I use a bulb as my load, and I'm applying this waveform, I'm applying this AC voltage here. If this this voltage source here is this. So let's assume, let's go back to this. Let's assume that V maximum, that's not our V peak is plus 5 volts, and let's assume here this is time, that's 0, minus 5 volts is our negative peak. Now as this rises from